So optimization, what is it? It is one of the most common things that you will see in calculus. For sure, it's going to show up on the AP test. Almost always it's going to be a free response type of question in some sort of way. And it's basically taking and figuring out what is the minimum or maximum values that we can find of a certain either shape, or think about a can and figure out how we can either maximize or minimize, like if we're talking about the volume. A lot of times, like I saw this when I was working at ConAgra over the summer, they kind of like were talking about different ways that they can like remake packaging so it's cheaper for them, so minimizing the cost in order to obviously maximize their profits, right? So this is kind of something, I don't know exactly if they do the same sort of model. I'm sure they probably have some sort of computer program that does it for them, but it does exist in the real world, so it is kind of cool that we're able to do it with calculus. So if we're going to look at one example before we kind of go over the steps for these are not always going to be the exact same, because obviously our shapes are always going to be different, okay? We might be talking about volume, we might be talking about area, we might be talking about perimeter. There's a bunch of different things that we'll be talking about for these. Now, another thing is that you'll need to know like your basic formulas, like area of squares, area of circles, perimeters of things. What's the other one that I was going to say? Volume, like basic volume formulas. If I believe almost always they give you the formulas for like volume of a sphere. If you don't know that one, or if it's some sort of crazy volume formula of something, they'll usually give those to you, okay? Same thing if it would be me giving it to you on a quiz or a test. I would expect you to be able to do area of circles and things, but if it was anything other than that, really, I would just give them to you, okay? So we're given this open box design of a square base and a surface that has 108 square inches. We're going to figure out the dimensions that the box should be in order to produce a box with a maximum volume, okay? So it says a square base. This picture does not necessarily relate that information. So you can also think about this being like, let's see how well we can draw our 3D shapes. Ooh, that was not great. You get the idea though, where this is X and H as well, right? So we're gonna try and figure out what is the maximum height and length for this in order to produce something with the most volume. But again, the top is open, okay? So we're given a formula about surface area. So hint, you're probably gonna have to write the surface area formula for this shape. We also are asked to maximize the volume. So we need to go ahead and write a volume formula for this shape. So if I'm trying to maximize volume, I need a formula for the volume of this shape. So if I go back to this shape, volume is just length times width times height, right? So what would my volume formula be? Yeah, X times H in this case, right? So X squared times H is equal to my volume. Okay, you always start with what you're maximizing or minimizing, your volume or your whatever formula for that. And then, however, we got to look at another formula because I have like 3 variables there. Okay, I can't really solve anything. So I need another formula, and it tells us which formula we should be using. It says surface area. Okay, so I need to write the area or the surface area of this shape. So that means the area of each individual side, right? So like the area of this first front box would be X times H, right? But how many X times H's are there? 4, right? So there's 4 of them. So I would have for my surface area 4xh, and then I'm also going to have, I wrote that on the wrong side there technically the X times H, I'm going to write this on this picture here. This would be here. And then on the bottom, I'd have X times X, which would be X squared. But I only have one of those because it's an open box, okay? So it would not be 2x squared for this one, it would just be plus X squared. And we know the surface area is equal to 108. Okay, so now I've got 2 formulas with both X's and H's in it. So I need to solve one of these so that I can plug some values in. Okay, we're trying to maximize volume, so I'm going to solve this surface area formula for X. Okay, so let's solve this for X so that we can solve it for H so that we can have an equation with just X's in it. Okay, so I'm solving this for H. So I've got 4xh plus X squared equals 108.
You didn't need to rewrite that.
I didn't, you're right. oh man, equals negative x squared plus 108. And then divide by 4x on both sides. So I get that h equals negative x squared plus 108 all over 4x. Okay, so now I'm going to take this value of h, and I'm going to plug that in to my volume formula. So my volume formula now is v equals x squared times negative x squared plus 108, all divided by 4x. Okay, and I'm going to go ahead and simplify this here. So I've got the volume is equal to negative x. Actually, let's just do ahead and cross out one of these with one of those. So I got my x's to go away. And now my volume is equal to negative x cubed plus 108x over 4. Okay, and I'm just going to write this as two fractions to make it easier for what we're about to do. So this is negative x to the third over 4 plus 27x. Okay, we've talked about minimum and maximums already. Okay, minimums and maximums, we're looking at when is the derivative equal to 0 or undefined. Okay, so from here, I need to go ahead and take the first derivative of our volume formula, and we're going to set that equal to 0. So if I take the derivative of this, I get negative 3x squared over 4 plus 27. Yes? Okay, and then from here, I'm going to set this equal to 0. And now we're just going to solve it. So I've got 27 is equal to 3x squared over 4. If I times that by 4/3 on both sides, I get x squared equals 36. So I get x equals 6 and x equals negative 6. Okay, now does it make sense for x to be negative 6 in terms of the problem that we're given? No, x cannot be negative 6. So we have to think about what is my feasible domain for the equation that we're given. So x cannot be negative 6. We cannot have a negative side length. So our x equals 6 is in fact going to give us our maximum volume for this this square, or this box, I guess I should say. Okay, so if it wants the dimensions, I can go ahead and solve for h by plugging it back in pretty easily. So if I plug this back in, h is equal to negative 6 squared plus 108, all divided by 4 times 6, which if we plug in the calculator, we get 3. Okay, so always make sure you're ending these problems with answering the question, and go back to double check you're answering the question. So it's asking us about what are the dimensions of the box. So the dimensions of the box should be, 6, and then be careful with units here. We have inches, right? 6 inches by 6 inches by 3 inches to maximize the volume. Okay, just one other thing I want to point out. You don't have to do it, but if we use the second derivative test, we can also find maximum and minimums by taking the second derivative. So let's just say I took the second derivative of this function here, and I would get negative 6x over 4, which is the same as negative 3 over 2x. And if I plugged in that x value of 6, so if I did v double prime of 6, I would end up getting a positive value. I would actually end up getting negative 18 over 2, so 9. Or sorry, negative 9, right? Negative 9, which is less than 0. And if you look over on the board over there, our second derivative being less than 0 is also a maximum, okay? But we don't have to do that. I was just showing you, like, the second derivative test works here as well to kind of test to show that that's a maximum, okay? All right. Any questions on that example? Okay, so here's your kind of guidelines or your steps that you're going to do in order to solve your optimization problems. And again, it's going to change every single time. The hardest part being either you have to draw a picture or you have to identify what your equations are that you were trying to solve for, okay? So first step is identify all of your given things. Like, for example, we were just given the surface area, right? So identify that and definitely write an equation for the surface area if that's what you're given. Okay, our primary equation, the second step here, our primary equation is what's being maximized or minimized. Okay, that should be the first equation that you're kind of solving and taking the derivative of after you have just one variable. But again, you might have to use a second equation in order to plug in to your first primary equation so that you can have an equation with just one variable. You just kind of got to figure out what that looks like. It's different for every problem. Make sure you look at your domain, right? What can x not be? If you get an answer for x and it's, incorrect, you can't have that, cross that out. And then again, figure out where the maximum or minimum value is occurring. Okay. All right, let's try another one. Okay. Example 2 here. We're looking at what points on the graph are closest to the point 0, 2. Okay, well, we're given a graph over there, but we don't have a picture or anything. So we need to go ahead and draw that picture. So y equals 4 minus x squared. What does that look like? X squared looks like a parabola. So if it's negative x squared, that means it's flipped upside down. And that 4 does what? Moves it up, right? So our graph for this is going to look something like this. Starting at 4, my parabola is just going to be upside down. So something like this. And we're looking, what is the x value or y value that is closest to the point 0, 2? So 0, 2, we're looking from that point. What is the closest value to the curve? Well, if I look at all the options, is that going to be the closest? Going straight up and down? No. Is it going to be closest here? No, probably not. Probably something like right here, right? That's going to be the closest, which is going to be equidistant from both sides, right? So I can figure out what both of those values are. We're going to just call this point x, y. I don't know what it is, right? What formula do we know about finding this length? Or do we at least know what it's called? If I have 2 points and I'm trying to find the space between them. The distance formula, okay? Does anyone remember the distance formula? Yeah, there you go. Your distance formula is equal to the square root of x minus x1, so your difference of x's squared, plus your difference of y's squared. That's just like your generic formula for that, right?
I remember doing that.
Okay, so now I'm just going to go ahead and plug in my value that I've been given. I don't know the x and y, but I am going to plug in the point x1, y1 as 0, 2. Okay, so I've got d equals the square root of x minus, bless you, 0 squared plus y minus 2 squared. And I might have mentioned this, but I might not have. Are we trying to minimize or maximize the distance? Minimize, okay? So I just usually like to write myself a note of what we're doing. We're minimizing this formula here. Let's simplify this. simplify this, it gives me x squared plus y minus 2 squared. Now the issue is that I have an equation with two variables. I can't take the derivative until I only have one value or one variable in my equation. Okay, so what am I gonna, like, what else do I have here? How can I plug in something for one of those variables? Is there another formula that I could get, or is there something in our equation that we're given? I see you nodding your head. Do you have an idea? Yeah, y equals 4 minus x squared, right? So I can just plug that in for y. And then I only have something in terms of x, right? So let's go ahead and do that. I have x squared plus 4 minus x squared minus 2 squared. And if I simplify this, x squared plus, this would be 2 plus x squared squared. And now we could take the derivative of this here with the square root and everything. 2 minus, yes, yes. Okay, back to what I was saying. We can take the derivative with the square root if we wanted to, but I think that's going to make us solving a lot more difficult. So instead of looking at like the square root of this, if I found, like, just how I kind of showed you up on the board about like that triangle here, if I had like a side length of 10 and 15 and I'm trying to find this one, I'm trying to minimize this distance or the distance between the parabola and that point. If I find the smallest value before I take the square root, that's going to also give me the smallest value, right? Like if I found the smallest of this to be technically the square root of 100, but maybe I found another number that was like the square root of 150, wouldn't the 100 be smaller than the 150? Yeah, so I can take the derivative of just the stuff underneath the square root to make our life easier. Okay, so we don't have to include the square root as well. We can just take the derivative of everything else. So I'm going to take the derivative of this function underneath here. But I am going to simplify it one more time. What am I trying to write here? This is the same thing as x squared plus 4 minus 4x squared plus x to the 4th, right? I just factor this out. So now let's take the derivative of that. Okay, so we're trying to minimize the derivative, this piece here. So I'm just going to call it d prime is going to equal 2x minus 3x. Oh, no. Oh, you're right. Let's do that real quick. So negative 3x squared plus x to the 4th plus 4. So my derivative would be negative 6x plus 4x cubed. Okay. And now that I've taken the derivative, I'm going to set this equal to 0. So if I set this equal to 0, I'm going to factor out my GCF. So I'm going to take out a 2x, be left with a negative 3, just negative 3 plus 2x to the 2nd. And that equals 0. So I'm going to get two answers here. I'm going to get that x is going to equal 0, and x is going to equal what? Yeah, the square root of 3/2. Plus or minus, exactly. Okay, so now we need to think about our problem that we're solving. Can x be 0? No. But could x be the other two? Yes. So we're going to omit the answer of 0 because that just doesn't make sense in the problem that we're given. Okay. And we are going to look at the values of the square root of 3 over 2. Okay. So these are the values that are going to minimize the distance between. So I need to find out what the y value is. Okay, so my y value equation up top was given to us as 4 minus x squared. So I can plug this in, 4 minus the square root of 3 over 2 squared. So y equals 4 minus 3 over 2, which if we simplify that, that's technically like 8 over 2 minus 3 over 2, which is the same thing as 5 over 2. Now, if I plug in the negative square root of 3 over 2, won't I get the same thing?
Yeah.
Yeah. So we can just go ahead and be done there, and we can say that the points on y equals 4 minus x squared that are closest to 0, 2 are the points square root of 3 over 2, 5 over 2, and negative square root of 3 over 2, 5 over 2. Okay, so this next one here, we're given a page of paper, okay? It says the rectangle page is to contain 24 square inches of print. Okay, that is this piece, obviously here in the middle. So that's 24 square inches, okay, on that paper. The margins at the top and the bottom are gonna be 1.5 inches, and the margins on the left and the right are 1 inch. So what should the dimension of the page be so that the least amount of paper is used? Okay. So we need to look at, first of all, are we looking at maximizing or minimizing based on the question that was asked? Minimizing, right? It says the least amount of paper. So we're looking at minimizing. And specifically, we're looking at minimizing the entire page, right? So what is the dimensions of the entire page of this paper here?
X plus 3 times y plus 2.
Yeah, x plus 3 and y plus 2. You're adding those margin pieces on the side, right? So my area of the entire page is x plus 3 times y plus 2. But again, we have two variables. Can't have two variables. We're given one other piece of information. And we're given the piece of information that this area here is 24. So how do I write an equation of this area? X times y, right? So my area of the equation there in blue is x times y. Okay? And then I need to solve for one of those variables so that I can have an equation with just one variable for the maximum or minimum equation that I'm using. So I don't care what we solve for, x or y. X, okay, if we solve for x here, I get 24 divided by y, right? So now I can take this and I can plug that in to my x equation there before we can take the derivative. So I got my area is going to equal 24 over y plus 3 times y plus 2. Now we could technically take the derivative right now without simplifying it, but I think it'll make your life easier if you simplify it first. So let's go ahead and distribute this to get just one kind of polynomial there instead of two factors. So I would get 24 plus 48 over y plus 3y plus 6. And if we simplify that, we get 30 plus 48 over y plus 3y. Now we can take the derivative of that pretty easily, right? So let's go ahead and do that. Go ahead and take the derivative of this function and set it equal to 0 to find out what are your values that we need to look at, okay? All right, do you guys get y equals plus or minus 4?
Yeah.
Yes? So which answer do we need to omit? -4. We can't have a negative side length, right? So my answer would be y equals 4. And then I can go ahead and take that y value being 4, plug it back in, but be careful because what is the question asking us? Is it question asking us about the size of the paper or the size of that blue text? Size of the paper, right? So we're using the dimensions of x plus 3 and y plus 2. So the dimensions of the paper should actually be what? Oh, we need to find x first, don't we? Ha. Let's find x first. If I find x, I get 24 over 4, which is 6, right? So I've got x, I've got y. If I plug that back in here, I get 9 and 6. Yeah, so my dimensions, kind of answer the question here. The dimensions of the paper should be 9 inches by 6 inches to minimize the amount of paper used. Okay, so we've got 2 posts. There is a picture for this one over here. One that is 12 feet high and another that's 28 feet high, and they stand 30 feet apart. They are steadied by 2 wires attached to a single stake running from ground level to the top of the post. Where should the stake be placed to use the least amount of wire? We're going to use our calculator to figure this one out because otherwise it would be impossible. So this entire length here is 30. Okay. Now, what are we trying to minimize or maximum? What was the question asking for? It says least amount of wire. So we're doing what with the wire? Minimizing the wire. Okay. Now, the formula for wire is given to us, right? On the picture there, it says that the wire is equal to that's a y. Y plus z. Okay, but I need to use those other numbers to help me kind of figure out what am I going to plug in for y and z so that I only have one variable. Okay, so I'm going to draw another little picture here. This is my small triangle, where this is 12, this is y. I've got another larger triangle. So I'm going to label this z, and then this was 28. Okay. Now the entire base there, technically there's no distance between here. They meet at one point. This entire length is 30. Okay. So we're just going to choose one of those unknown sides. We're going to call it x. Okay. So I'm going to call this unknown side here x, which would make this other unknown side be what? 30 minus x. Okay. If you chose to do it, x on the larger one and 30 minus x on the smaller one, that's fine. Just make sure you know what your x stands for in terms of the problem. So our x value that we're going to solve for is the distance away from the 12-foot pole, okay? So looking at these triangles, what formulas could we do in order to solve for y and z in terms of one variable?
I don't know, trigonometry?
I don't have any angles or anything. Pythagorean theorem, yeah? I could write the answer, or not the answer, but I could write a formula for y in terms of 12 squared and x squared, right? Same thing for z. I could write a formula for 30 minus x and 28 in terms of z. So let's go ahead and do that. So I've got y squared is equal to 12 squared plus x squared. But I want to solve for y, so I'm just going to take the square root. So square root of 144 plus x squared. Okay, if I solve for the side length of z, z squared is equal to 30 minus x squared times 28 squared. And then I can take, or sorry, plus, that should be a plus there, huh? And then I can take the square root to find just z. So z is equal to the square root of 30 minus x squared plus 28 squared. Now, if you wanted to simplify it, you could, and you would end up getting this simplified answer right here of that x squared minus 60x plus 1,684. However, if I were you, I would just leave it like this. Okay, because now what we're going to do is we have a value for x and we have, value for y and a value for z. And I'm going to take these values that are only in terms of x and I'm going to plug it into my formula. Okay, so y, sorry, that's a w. I can't figure out my letters today. So w is equal to the square root of 144 plus x squared plus the square root of 30 minus x squared plus 28 squared. So we're looking at minimizing this function. Okay, so another way to minimize functions, right, is we can just literally look at the graph and see where is it the smallest. Yes? We can also take the derivative and say, well, when is that derivative equal to 0? That's the point at which the value is either minimum or maximum. Okay? So if we don't want to take the derivative of this, and if we do, it's going to be really gross if I set it equal to 0 and try and solve. I think it's actually impossible to do. Maybe not. It's probably possible, but it's a lot easier if we can just use a calculator. Okay? So on our calculator, I would like you to put, I'm going to kind of write out the steps here. In your y1, I would like you to put this value of w. Okay? So this whole thing, I want you to type this into your y1. Okay? Including all the square roots and everything. And then once you've typed that in, you will hit second trace and calculate your minimum value. Okay, when you hit your minimum value, it will say left bound, right bound, and then guess. So you just hit enter after each of those. Okay, you almost 100% likely will need to change the window by going to zoom and just zooming out until you can finally see the graph. Okay, so go ahead and try this out. You should find the intersection point to be 9,50. And if you don't, let me know and I can come help you. Okay. So our answer is 950, but what does that mean in terms of the problem? Our x value is 9, our y value is 50. So that means, oops, if we were answering the question, because the question again asked us where are we going to place the stake so that we use the least amount of wire? Well, we are going to place it 9 feet away from which pole? The 12 foot or the 28 foot? 12. The 12 foot, right? So we're going to use the least amount of wire place the stake 9 feet away from the 12-foot post. Or would it be or 50 feet away from the 28-foot post?
50.
Wait,
No. It would be how many feet away from the 28-foot post?
Oh,
Yeah, 21. Or 21 inches, or sorry, feet away. Oh.
wait.
This should just have one tick mark, shouldn't it? For feet. My bad. 21 feet away from the 28-foot post. Okay, one of those two things is sufficient enough, but make sure you answer the question of what it was asking. Yeah, this should probably be and there. There we go. So, last problem here. We've got Rick wanting to make Morty a holiday decoration, and he has 4 feet of wire that can be used to form a square and or circle. How much of the wire should he use for the square, and how much should he use for the circle in order to make an ornament? So we're looking at how much of the wire should he use for the square and the circle, and then we're trying to find the maximum total enclosed area, okay? Keyword here being and or circle, okay? So, to start us off, if we have these two things, area of a square and area of a circle, if I'm trying to maximize the total enclosed area, that means I am finding the area of both and adding them together to maximize it, okay? So the area that we are maximizing, kind of our first equation there, we are maximizing the area formula of pi r squared, which is the circle, plus x squared, which is our square. Again, I can't have two variables, so I need another equation. And that other equation can be found by using the other information that was given to us. That other information is what? Anyone know?
The perimeter?
Yeah, it says 4 feet of wire, right? 4 feet of wire looking at the perimeter of our square and the perimeter of our circle. So we're given those formulas there. So my perimeter of each of those things, 4x plus 2 pi r, would have to equal 4, right? So if I solve this equation for r, then I can plug that expression in to my first equation, and I'd have one equation in terms of x, okay? So I'm going to solve this for r. So I've got 2 pi r is equals to 4 minus 4x, divide by 2 pi, and I get r equals, I'm going to go ahead and simplify this, divide all these by 2. So I get 2 minus 2x over pi. So now that I have my value for r, I'm going to take this and I'm going to plug it in to my formula over here. Okay, so I've got my area formula is pi times 2 minus 2x over pi squared plus x squared. Okay, before I take the derivative of this thing, let's simplify it to make our lives easier. So I get a equals pi times, this would be 4 minus 8x plus 4x squared divided by pi squared plus x squared. So then my pi's would go away, so I'd be left with just 1 in the denominator there. So I've got 4 over pi minus 8x over pi plus 4x squared over pi plus x squared. And now we can go ahead and take the derivative. So my derivative of this, first one, what happens here?
0.
That goes away. The derivative of negative 8x over pi would be
Negative 8 pi?
negative 8 over pi, yeah. And then I would have 8x over pi and 2x. That's my derivative of all those pieces. Okay, and I'm looking at when is this equal to 0? Okay, so let's factor out an x out of those first two, or the last two terms there. So I have 8 over pi plus 2 times x, right? And then I'm going to move that negative 8 over pi to the other side to be 8 over pi. We okay with that algebra there? And then if I'm solving for x, I would divide. So I have 8 over pi, and I'm dividing that by 8 over pi plus 2. Which again, just do a little bit of algebra. I could simplify this to be 8 plus 2 pi over pi, yes. So then this is, yeah, we multiply by the reciprocal. So technically this is multiplying now by pi over 8 plus 2 pi. Pi's go away. And then I could simplify all these numbers by 2. So this would be 4, 4, and 1. So x is going to equal 4 over 4 plus pi. Okay. But we do need to account, because this, back in the original question, it said and or, right, for using either a square and or a circle. So we need to look at not only this answer is our answer and we're just done. We need to look at the endpoints as well. What if I did not use any, what if I didn't use any string on the square? If I didn't use any string on the square, what would my x value be if I look at this picture? If I didn't use any string on the square, or sorry, wire. Yeah, 0, right? What if I used all my string on the square, or the wire on the square?
16.
Your x would be, well, x would be 4, right? Because there's only, wait. Yeah, because 4 times 4 gives me 16. Wait, what am I saying? Oh no, if all 4 feet was used on the square, all 4 feet here, right? If this was equal to 4, then it would be x is 1. So each side length would be 1 foot, right? Does that make sense? Yeah. So we're going to test 3 points here. I'm going to test the point when x is equal to 0, when x is equal to what we just found, which is 4 over pi plus 4, and I'm going to look at x being 1, okay? This is if I would use no wire on the square. This would be if I used wire on both the circle and the square. And this would be if I used all 4 feet on the square. And our area formula back up from the beginning was x squared plus pi times 2 minus 2x over pi squared. So just to save us some time, if we would plug all of these 3 values into my function for the area, I would actually end up getting approximately 1.27, approximately 0.560, and approximately 1. Now, of those 3 things, again, minimums and maximums can occur either in between the interval, or it could occur at the end points of your interval as well, right? And since this one says that we could either have a circle or a square, we do need to occur and test both of those endpoints as well. So looking here, which one's actually going to give us the maximum area? Yeah, if we have no wire using on the square, which gives me an area of 1.27, meaning that we're only going to make that ornament with the circle as our shape, okay? So to answer our question, Rick should use all 4 feet of the wire to make the circle the maximum area. So that one was hard. Okay, there won't be one like this on your homework, but on your homework, I do want you to try 5 to 6 of them. I don't care which 5 to 6 you do on the optimization. And I will update that on Schoology to reflect that assignment change as well. And then also, please, please, please look at the summative review. Your summative review is not in the folder for today, but it's out in a new folder called Review Materials for Unit 3 summative. So go grab that. Try out those problems. Come with questions on those next class so that we can have kind of a little bit of a head start on looking over some of that old stuff that we haven't thought about in a while. Okay? We'll have 2 days of review next week. Test will be that Monday with a review before your final and last test on Friday of finals week. Okay?